everyone. Welcome to one of two videos on our new topic of inverse functions. It is the last topic for our first unit, so expect us to have a lot of review for next week. So this we're talking about only graphs and tables, but if you don't know what an inverse function is, effectively it's a function that's complete reverse of itself. The domain and range get swapped, all the x's become the y's, and the y's become x's. But if you want a more like visual example of this, I like to always compare it to an escalator. Imagine the process of going to the top, from the bottom to the top in this direction as our f of x. Then the process of starting at the top and going for the bottom would be our inverse, this little -1, if you want to put that there. That usually just represents inverses. So that's always a good way to remember what an inverse function is. It's just, instead of going from the bottom to the top, you're going from the top to the bottom on escalator. So let's take a look at this right here. Here we have our original function. We don't have an equation. We're just looking at this table, and then we're looking at this graph. And what we're going to do is, all we're going to do is we're going to take these x's and these y's, and we're going to swap them around. So -2, 3 becomes 3, -2. -1, 0 becomes 0, -1. 0, -1 becomes -1, 0. 1, 0 becomes 0, 1. And 2, 3 becomes 3, 2. So I think this is like one of the easiest things in math is to make an inverse table, is you're literally just taking the x's and y's and swap it around. So the process isn't hard, but you just have to remember what an inverse is, all right? So just keep that in mind. Now, when we take a look at this graph here, let's try to graph these new points. So let's graph 3, -2, 0, -1, -1, 0, 0, 1, and 3, 2, and then we connect them. So this is what the inverse function graph would look like. And if you ever wonder, like, how can I tell if I graph this properly? Well, if you actually just draw a diagonal, now if you just tilt your head to the side, you'll notice that the upper part and the bottom part of the diagonal are pretty much perfect mirror images of each other. So there's that for graphing. But real quick question, guys. Do you think that the inverse of the original function is itself a function? Isn't there a really easy way to tell visually if something is a function or not? Remember the vertical line test? The fact that I'm hitting the inverse function, in quotes function, multiple times on a graph when I'm drawing a vertical line means what I actually made wasn't even a function, but it is the inverse of this original function. It's just not a function itself. So sometimes inverses of functions are not actual functions. It's kind of weird, but it happens sometimes when you flip them over like this. So this is just how you create an inverse table and the graph of an inverse function. And we'll give you guys a few chances to practice this, but I feel like at least this part isn't what's going to like make you guys have too much trouble with inverses. We have one more video though that focuses on the trickier part, which is equations. So look forward to that.